Hey guys, welcome. We are doing the 11-7 evens. So here we go. Are the two figures similar? If so, give the scale factor of the first figure to the second figure. So in order to figure out they're similar, we have to have proportional sides. And so what you're going to do is you're going to take all the sides that are corresponding to one another. So for example, this will match with that. This guy matches with that guy. And this guy matches with this guy. So once we have our proportional, our corresponding sides, then we're going to set proportions. I'm going to go left to right, left on top, right on the bottom. And so the yellow is going to be 3 to 5, green is going to be 3 to 5, and blue is going to be 3 to 5. Since all of these are already reduced, they're similar. They have the same exact ratio. So if they have the same ratio, then they are similar. So we say yes, similar. Okay. That one was a little bit too easy. So let's go to number 4, where we are going to highlight our corresponding parts. So this is 6 to the 2, and then we have 12 to the 9. So I'm going to go left on top, right on the bottom. So we're going to go 6 to 2 equals, and that's going to be 12 to 9. So keeping that consistent. So this is the yellow group, and this is my blue group of problems. Okay, and so what we want to do is we want to reduce this. Well, 2 goes into that. That's 3 times, and then that doesn't actually go in evenly. It goes in 1 time with about, 3 left over. So it's not going to be 3. So these are definitely, we'll just reduce this to 3 over 1. 3 goes into both, so that's 4 over 3. Those are not equal, so this would not be similar. So not similar. So if you get your ratios to be unsimilar, then they're not similar. And that's what you do. Let's move on to the next one. Okay, so number 8 here says each pair of figure is similar, so we already know they're similar. Use the given information to find the scale factor of the smaller figure to the larger figure. So let's just do a recap here real quick. So we learned last chapter that this right here is called the scale factor. So scale factors are whenever you're doing one-dimensional items with each other. And this guy right here is called our area ratio. And that's when we're comparing our areas. And then our final one is our volume ratio. Okay, so I have them set equal to each other, but technically they're not equal to each other because I'd have to either square root, square, cube root, cube, all sorts of different things in order for this to work. So what happens on number 8 here is that we're given volumes. So we're going to be starting out with the cubed version, and it's asking us to go all the way back to get scale factor. So we have to go from a cubed, b cubed, all the way to a to b. Okay? And so to do that, what we're going to do is we'll take these. It doesn't matter what order, so I'm going to do 125 over 216. So right now that's in my a cubed to b cubed, and I need to go all the way back here. So how do I go from a cubed to a? Well, I'm going to cube root that. So we cube root it. Now, you probably don't notice, but these numbers are actually very generous to us. We can cube root. I'm going to show you on this calculator first. So this calculator, you have to hit 3 first, and then you're going to hit this little caret symbol, but before you do that, you have to hit second. So second caret 125. And when you cube root that, you get 5. So that's going to end up with 5. So this is going to be our a to b, and this is our a cubed to b cubed version. And then 216, so let's do it with this calculator here now. This one actually has a cube root function by itself, so you just hit shift, that key, and we're going to do 216. We get 6. So we cube root to go from here to here basically. Okay, so 5 over 6. So my answer is, what is the scale factor of the smaller to the larger? So I put the smaller on top, the larger on the bottom, and we get this guy right here, 5 over 6. Number 10. So number 10, we have same thing, small to large. So we're going to do 36 pi over 121 pi. Now, first things, I'm going to just cancel those out. That's going to make it a lot easier. But when we look at this, we are looking not at a cubed, we're looking at a squared. How do I know it's squared? Because it says SA. SA is surface area. Even if you didn't know it said surface area, but you see it says feet squared. So this is a two-dimensional. So we're at a squared, b squared, so I need to get this into the correct form. So since I want the scale factor, I'm going to have to get it to a to b, but to do that we're going to square root instead of cube root. So let's square root. So 36 square root, you could probably do that in your head, that's 6, and 121 square root is 11. And so you're left with 6 over 11. So it's really helpful to have this kind of little setup right here where you can kind of go back and forth and say, all right, what do I have to do to get to which one? Okay? All right, moving on forward. So for number 12, it says the surface area of the two similar figures is given. The volume of the larger is given. Find the volume of the smaller. Okay, so we're starting out. This one's kind of confusing, but let's go to here. We're starting here, and we're starting with our area ratios. Okay. Now, I can't go from here to here because I don't. To get from here to here, I have to multiply by a, but I don't know what a is. So this is kind of funky. I have to start here, go back to here, and then go over here. Okay? So I'm going to start here. I'm going to square root to get back to the scale factor. Then I'm going to cube it to get to the volume ratio, and then I can set up my proportion. Okay? So it sounds confusing, and that's because I would say that it is slightly confusing. So here we go. I'm going to grab a new sheet of paper for this. Alright, and we want to find the volume of the smaller, so it doesn't matter how we set this up. But right here, we're in our a squared to b squared. So we're going to want to go to a to b first. So before we do anything, I automatically see that this is not able to be square rooted. 108 is not a perfect square, so I'm going to go ahead and assume we can simplify this. So if you don't remember how to simplify in this calculator, the other calculator does it automatically. So you do 108, and you hit this button that says a, b divided by c, and then we do, 192. So always reduce the fraction, and look at that, you get 9 over 16. So this is still square rooted, right? Okay, so this is still our area ratios I just simplified. Okay, so we get 9 over 16, so this is after I simplified it down. So I still want to go from here to here, so I'm going to have to square root. Remember, so square root, that's going to give me 3 over 4. So that's my a to b now. And now I want to get to a cubed, b cubed. So to do that, I have to cube it. So I'm going to cube these. So 3 cubed and 4 cubed. Alright, so this right here is my 27 over 64 is my volume ratio. 3 over 4 is actually my scale factor, a to b. And then 9 over 16 is my a squared, b squared. And you can see that because what's 3 squared? 9. What's 3 cubed? 27. Okay, so it's just kind of a funky pattern. But once we have this guy, and this is what's important, the volume ratio, once we have that, we can actually set up a proportion to find the volume of the smaller figure. So I can take this one now and set it equal to, I don't know the volume of the smaller one, which is on top, but I know the volume of the bigger one. Now I can actually set up my proportion and solve because I have the right ratio. I started with the area ratio, had to go back to the scale factor, and then cube it to get the volume ratio. Now I can cross multiply. Okay, so 27 times 1408 is going to give me this really large number. And then we're going to divide by 64. So x ends up being 594. And we should put in our units, which is cubic inches. On the Go formative, you can just leave it as 594. Alright? Very good. Okay. So those are probably the most time-conducive ones until the next one. Okay. Let's move on to 14. Find the volume of the two similar figures are given. The surface area of the smaller is given. Find the surface area of the larger. Okay, so on this one, so up here, we're given surface areas. now we're given volumes. Okay, so I'm going to try and make this one a little bit easier to see. That might not be true. But here are all three of ours, right? Volume, surface area, and scale factor. Okay, so they gave us the first one right here. Alright, so we want to change that and convert it over here. I can't go from here to here, even though that's what I want to do. And so I have to go all the way back here. So to do that, I'm going to take this. So I'm going to leave these up here as like these are, these are kind of like the standalone. So to move this, we can't simplify this fraction really. I'm going to cube root this and send it all the way back over here. Okay? So we're going to do the cube root of 8, which is 2. And I'm going to put that up here because that's going to be our final answer. And then cube root of 27 is 3. Okay? So there we have our scale factor. Okay, so I went here and I was able to get it by cubing it. Now I need to get to my surface area because I'm dealing with surface areas here. So to get that, I need to go, this needs to go over here, and I have to square these. So that's going to become 4 over 9. Now the goal is you have something that looks relatively perfect, right? A squared, which is 4, so 2 squared is 4, and 2 cubed is 8. That works perfect. 3 squared is 9, 3 cubed is 27. So those are perfect. We have our scale factor, our area ratio, and our volume. So if you can figure out how to move back and forth in between those, whatever makes most sense to you, I always go back to scale factor, because from scale factor you just have to square or cube things. It makes it a lot easier. Alright, so to set this one up, we're going to use our scale factor because everything is in, or sorry, our volume ratio, because everything I have 36 and 25 was what I was given. I'm sorry, I'm looking for volume. Messed that up. Okay. I'm looking at the wrong problem, that's why. I was like, wait, I knew I was supposed to do it with the scale factor. Whew, my bad. Okay, so I do want 4 over 9. And 36 is the surface area of the smaller, so we're going to put 36 on top, and I don't know x on the bottom. Okay, so now that we have the right one. So now we can cross multiply. We're going to get 9 times 36. $324 equals 4x, and then divide by 4. You get x equals 81. So that's 81. And these are in, keep doing that, I keep looking at 11. So that's in square meters. Just like that, okay? Alright, that's it for me. I would do 16, but those ones are really important for you to practice. I'd rather you practice that one, so I'm going to actually leave off 16, and there's no back page to that. So we are done. Good job for you.